At this point, everyone in here should have the original surface area and original volume completed. So Holton, what did you get for the original surface area of this prism? And how did you get that? Well, no, let me ask someone else. How did you get 100 centimeters squared, Trajan?
Find the surface area.
Find the surface area, and what formula did you use?
Perimeter times height.
Plus
2 times the base.
Beautiful. So that's the formula we used here. And we got 100 centimeters. And then Emma B, what did you get for the original volume? Beautiful. 56 centimeters cubed. And what formula got you to that answer, Genevieve? Beautiful. Area of base times height. Now, what I want you to do, using these exact same formulas, it now asks, what are the effects on the surface area and volume if the dimensions are tripled? What does tripled mean? So what are you going to do with these three dimensions that they give us here? 7 centimeters, 2 centimeters, and 4 centimeters. Yeah, you're going to multiply each one by 3, and then using those new numbers, I want you to find the new surface area and new volume. So, what did you get for the new surface area, Tamaras?
I got 352 centimeters squared.
You got what?
352.
What did you get, Serena? 900. And what did you get for the new volume, Haley?
15.
Beautiful. Now, yes, I know that your immediate knee-jerk reaction here was just, oh, let's multiply the surface area by 3 to get the new surface area. Is that what happened here? Ah!
Sunderland, you have a mistake.
I have a mistake. Oh, I do have a mistake. Thank you. Cubed. Okay. So, why do you think we're multiplying by 3 twice? Yes, Liv.
Centimeters squared.
Ah! How many dimensions is surface area? Area is always 2 dimensions. Meaning, we're not just changing one of the dimensions here, we're changing 2. So for each dimension, we need to have a 3. So instead of just multiplying the surface area by 3, what are we multiplying by?
3 squared.
3 squared, which is 9. So we're multiplying 100 times 9 to get 900. This works every time. Anytime you have surface area, you're changing 2 of the dimensions.
Oh, wait, so we're doing the other two.
What if it had said double? Double all of the dimensions. What would we be multiplying by then? 4, right? 2 times 2 is 4. What if it said to quadruple?
8. 16.
Right, 2 times 2 times 2 times 2, which is 16. Oh wait, no, what did I just say? No. Quadruple. So it's 4 times 4. I can't, what was I even saying? I don't know. 2 times 2, no. 4 times 4, yes. So here, we can apply the same concept. So how many dimensions is volume? 3. So I have 3 dimensions here. Each one is multiplied by 3. So are we getting 3 times larger with volume? How many times larger are we getting? What's 3 times 3 times 3? So all I had to do here was multiply by 27 to get my new volume. Does this make sense?
Wait. Is that the case for every time?
Every time.
So if you want to find the volume and you have the original volume?
Yes, you don't actually have to solve for the new volume. You just,
By 27?
so volume is always 3 dimensions, right? Always 3. So it said triple the volume. That means for each one of the dimensions, you need to multiply by 3. So it's going to be 3 times 3 times 3, which is 27.
So this is like the
So you multiply by 27.
just 27 every single time.
If it's tripled.
It's cute. Just whatever. How many times you're like.
If it's not triple, then
If it's doubled, what would it be?
2 cute.
It'd be 2 times 2 times 2, which is 8. 8 times larger.
How much it is.
Right. So here it says, what is the effect on volume if only the length and width are tripled? So how many dimensions are changing now? Only 2 of the how many for volume? There are 3 for volume, but only 2 of the dimensions are tripled. So I only put 3 for 2 of my dimensions. The other one remains the same. So what is 3 times 3 times 1? So our new volume is 9 times larger. Oh,
Larger from the original?
yes, from the original. Is this making sense? No?
Yes. Actually, it makes sense.
That's true. Does anyone need a better clarification? All right. So then you guys go ahead and on the back, you're going to try 1, 2, and 3. Do examples 1, 2, and 3 with these concepts in mind. All right, so what did you get as the answer for example 1, Vu? No, take it back, Julie.
That the
Here's it.
1,000.
So Vu just got 5,040 what?
M2.
Meters squared. Good. And how'd you get that, Vu?
Triangular prism. I used the method, the model, and I plugged it in.
Okay. So how many dimensions are changing for surface area?
Huh?
How many dimensions change for surface area?
3, 2,
Area.
2,
2, right? And we're wanting to do what to these dimensions? We're wanting to, what are we wanting to do to these dimensions?
We want to quadruple,
Ah, which means multiply by?
multiply by
Good. So what is 4 times 4?
16.
So it is 16 times larger. So all we had to do to find our new volume was multiply the original volume by, area, multiply the original area by 16, and you get 5,040 meters squared. Any questions there? Does that make sense to everybody? All right, example 2. How many times larger is the new volume, Sean?
540.
Number 2. How many times larger is it?
220.
9 times. And how'd you get 9 times?
Because it says triple to 3 times 3.
Why are you multiplying 3 twice?
Because it says triple to twice, so 3 squared, so I can know that.
Okay, so the original formula for volume of a cylinder is pi r squared times h, right? And we know that because the diameter is tripled, the radius is tripled. So the radius accounts for how many dimensions in our formula? 2 dimensions. That's why 2 of our dimensions are being tripled. because radius is 2 of the dimensions. So 3 times 3 times 1 is 9 times larger. And that's our answer. Are there any questions there? Do you want me to go more in depth?
I have a question.
Yes, Tamaras.
So like, why do they consider the radius as 2 dimensions?
So, when you think about it, this formula can be broken up into pi times r times h, right?
Right.
The reason why, and we do have, for both surface area and volume, we do have 3 numbers, right? We still have length, width, and height for a prism. But the reason why surface area is only 2 is because you're not multiplying all of the variables. Volume, you are multiplying all 3. So we have to look at how many variables are being multiplied here. Well, 3 are being multiplied, but 2 are the same. So that's why radius is 2 of our dimensions.
Yeah, I know, but like, how does like this, you know how the regular, just like, rectangular prism, they have 3 dimensions on one side, another side, and another side.
Yes.
How did they come to the conclusion that radius counted as 2 dimensions?
Like y radius squared.
Yeah, why radius squared?
I'd have to think about that one. That's a toughie. Like, why are they radius squaring? Somehow they derived the, I mean, it comes back to the equation for a circle. Let me think about it.
Because like when the equation for a circle, radius is squared.
Right, but, oh, I thought you were asking, like, why even that is squared.
Yeah, why?
Yeah, I have to think about that one. All right, number 3. Bhargav, how many times larger is our new shape?
1/4.
Yes, and how'd you get that 1/4?
1/2 times 1/2.
Right, only 2 of the dimensions are changing, so 2, the length and the height are being halved. That means 2 of them are being halved and 1 is staying the same. So 1/2 times 1/2 times 1 is 1/4 times larger. Now we had this debate in 4th period. Why is it larger? If I wanted to say smaller, what would I have to say?
Oh, I got how much smaller.
Yes, 4 times smaller, if we wanted to say smaller.
So it'd be, you would word it 1/4 times.
Yeah.
Why? Wait, what?
That just make a difference.
Wait, it's still 1/4 times larger though, right?
Yes.
Is that
It's either one, 4 times smaller or 1/4 times larger. Because when we say larger, we're insinuating multiplying, right? So we would multiply by 1/4. When we say smaller, that means dividing. So we would divide by 1/4. Both those things are the same, just different wording. Any other questions here? Cool.